Okay, so now we're going to look at the more complex method of charging, which is called charging by induction. It's a way to allow us to get the opposite charge from the object we're starting with, and it involves a multi-step process. It's explained here. An uncharged metal pop can is attached to a styrofoam cup. That's an installation stand. The negatively charged balloon is brought near the pop can, and then the balloon is held near the can is touched. That's going to be grounding. When the can is pulled away, the pop can will become charged. This process, again, is known as charging by induction, so it's multiple steps. When the balloon is held near the pop can, so we bring the balloon near but not touching, we're going to get a polarization inside the can. Now, like charges are going to try to get away, so the negative charges are going to go away, leaving the positive charges behind. We have polarized the can. So it's going to be B in this case, not A. Can't be. We have not charged the can yet. Now, when we touch it with the hand, we're going to ground it. We're going to allow electrons to move, and they're going to move since these electrons don't want to be near the balloon. They're going to move into the finger, okay, and through the ground. Now, that's going to leave behind the opposite charge. So the electrons are going to move from the can to the finger, can to the hand. Now, since we've gotten rid of electrons, then we end up with the opposite or positive charge. So notice we started with a negative balloon and we got the opposite charge, a positive charge on the can. So induction is the process that we can do that with, get an opposite charge from what we started with. If we touch and charge by conduction, we're always going to get the same charge. When the induction charge process is complete, we have not done anything to the balloon, so it's still negatively charged, and we didn't even take any charge away from the balloon as we would have with conduction. We just used the balloon to polarize the can. In general, if we use a negatively charged object to charge by induction, we'll always get positive charge, and vice versa. A positive charge will always get us a negative charge. So here we have a similar process. This time we're going to use a positively charged balloon. Okay, so while the balloon is held near the can and before it's touched by the hand, the distribution of charge is best depicted by the diagram. Again, the positive charge is going to pull electrons to it, leaving the protons on the other side, polarizing, setting up two poles. The easiest way to think of polarize is think of north and south poles in a magnet. That's where we use that word pole all the time. North and south pole of the Earth. The Earth is like a big magnet. In this case, it's positive and negative poles. It's going to be this one because opposites attract. When you touch by the hand, now this time, these electrons are being pulled toward the positive balloon. So if we touch with your finger here, then they're going to try to pull more electrons in from the ground. So electrons, it's always the electrons that move, can't say that enough, are going to move from the hand to the can, which is exactly the opposite of what we did before. Since we started with positive, we end up with negative, we get the opposite charge. Okay. So the two steps in induction are essentially the polarization step. So first you bring something charged near the item, and the item polarizes, sets up charge on one side and the other. And then the charging step is grounding. We bring in a ground. That will allow electrons to escape or pull electrons in, depending on what type of item we are charging it with. Now, in the items above, if you touch the two cola cans together, that's charging by conduction. If they're not charged, then they're all going to stay neutral. What's going to happen here is positive charge is left behind here. Negative charge is going to try to go as far away from that charge as it can. So it's going to go all the way over here. Now, we have created polarization here, but we've made a special polarization. We've polarized two separate cans. So when we separate the two cans, this one has a net negative charge, leaving behind a net positive charge on the first can. So we've been able to charge the two cans by a similar process of induction, in that we've induced charge, polarized the two cans, and then by separating them, we leave the charges on each individual one. Okay, so what we've done there is complete objective 6.2.2, state and apply the law of conservation of charge, and you should be able to describe the process of charging by friction, charging by conduction, and charging by induction. So in each case, it's a matter of following the electrons as they move from one place to another. If ground is involved, then they might move into the ground or pull out of the ground. That's one of the reasons why in a lightning storm, being flat on the ground is not a good idea, because the lightning is going to go into the ground. It may go through you if you are providing too much of a target. So in electrical processes, follow the electrons. They could be going into the ground, they could be pulled out of the ground, they could move between objects, especially conductors. Part of the process might be polarizing the conductor, creating a positive and negative pole. Part of the process might just be transferring charge by friction. In any case, the total charge of the system will be conserved. So whatever charge left, like say the soda can in the pictures above, had to go somewhere. It went into the ground, or it went into another can, or if you touch the balloon to it, it might go into the balloon. And that's it.